Now that you have successfully soldered all of the components onto the circuit board, we're going to move on to step 4, the programming step. In this section, we will walk through how to turn this assembled circuit board, which was built in step 3, into something that can actually record temperature. Now, we will do this by uploading Arduino programs onto the Atmega 328 microcontroller and the PIC12 that you bought from DigiKey, and then run these programs to install the temperature probes that we built in step 2, and then finally run the commands to actively log temperature. So let's get into it. In this step, we are going to initialize the Atmega 328 28-pin microcontroller so that it can accept and run an Arduino program. So for this step, we're going to need our Arduino Uno. We're going to need the USB connections from the Arduino Uno to your laptop. You're going to need the AVR ISP shield with the 0 insertion force socket. And the Atmega, the chip itself, the 28-pin chip itself, and then also the Arduino IDE software. So first I'm going to show you where to download the latest version of the Arduino IDE and how to operate it. So here I'm going to show you how to install the latest version of the Arduino IDE software. So on your internet browser, head over to www.arduino.cc, so it's not .com, it's .cc. Then once you have this web page, you're going to want to head up to software and then click the downloads option. And then you're going to scroll down to the download section. And as of today, we're on version 1.8.13. And here you can see the download options, so for Windows, for Linux, or for Mac OS. Select the operating system that you're running and follow the on-screen prompts to download the software. Once you have successfully installed the Arduino software, we're going to hook up our Arduino Uno to our AVR ISP shield, and then set in our Atmega 328 pin inside the 0 force insertion socket, and then hook up to our computer. So to do that, first we're going to combine these two. So the pins of the ISP shield are going to go into these sockets of the Arduino Uno, and you're going to line up the pins on the far right with the sockets on the far right. So like this, and then press it down firmly so that you have solid connection, and the edges of the two boards should line up. Next, we're going to make sure the lever is up. The lever has two positions, up and down, so we're going to make sure the lever is up, and that means it's open. And we're going to take our Atmega chip and we're going to insert it into this socket. But before we do that, you want to notice that this microcontroller has a notch on one side, and we want to line that notch up with the outline notch on the ISP shield here, and we want to put it all the way up to the far right. So with the lever up and the socket open, we're going to drop our microcontroller into the socket with the notch facing right, lining up with the notch here. And we're going to firmly press down on the lever to lock the microcontroller in place. Next, we're going to hook this up to our laptop via USB. So we have our one USB that plugs in here, and we have our other USB that will connect to the computer. And when we... Now you're going to want to open a sketch from the Arduino software. And in this sketch window, we're going to want to click select Open. And from this drop-down menu, we're going to go to Arduino ISP. And we're going to want to open Arduino ISP. We can close this previous sketch just so we have this one open. Now this is we're going to upload this to the Atmega 328. We're going to upload this program here, this code, via the USB, via the ISP Shield, and then via the Arduino Uno. So the first thing we want to do is we want to go up to Tools, and we want to make sure that we select Arduino Uno here as our board. And then under Tools again, we want to go to the port, and we want to make sure that we select, these will be all your serial ports that you have as options, and you want to select the USB serial ports so that your computer actually is talking to the correct device. And then from here, we want to make sure this programmer option is Arduino as ISP. And then when this is all set up, we're going to upload. And you'll have a little message here at the bottom of your IDE, and that's going to say uploading. And your the lights on the Shield and Uno should be flashing. And then when it's done, it'll say done uploading. And that's the first step. And then the next step is we're going to go up to Tools, and then we're going to select Burn Bootloader. With this window still highlighted. So select Tools and then Burn Bootloader. This might take a minute. And then when it says Done Burning Bootloader, you can close out of this and unplug the Uno from your computer, and we're done with this step. Okay, so here we are with our completed circuit board and the Atmega 328 chip microcontroller that we just programmed via the Arduino Uno and ISP Shield. And so this we're going to insert into this 28-pin socket. Now before we do so, you want to make sure that the notch on the Atmega is in the same direction as the notch of both the socket and the outline on the circuit board. So when you're confident on the direction, we're going to take this chip and we're going to place it gently on top and make sure all of the pins are lined up, and then press it into the socket. Now when the chip is correctly in the socket, it shouldn't wiggle, it shouldn't fall out, and you can take a look at the pins, and there should be no bends on any of the pins of the microcontroller. Okay, that's step 1 done. On to step 2. In this section, we will be programming the PIC12 F683, or for PIC12 just for short. And then we will be inserting it into the board. And for this step, what we're going to need is we're going to need our microchip PIC 3, our 0 insertion 4 socket that accompanies the PIC 3, as well as a micro USB to USB. And we'll also need a little bit of software. For this step, we're going to need to download 2 pieces of software. We're going to need first the Mplab X Ide and also the Mplab X C8. So to find those 2 pieces of software, we're going to head over to the microchip website. So using your internet browser, go to www.microchip.com .com, as you see here on my screen. And then we're going to hover over the Tools and Software menu, and then from the Tools and Software, we're going to hover down to the Mplab X Ide, and we're going to click on that. Okay, that's going to take us to a new web page. And on this page, we're going to want to scroll down till we see Downloads, Documentation, and Other Resources. And under this, you will see this hyperlink here that says Archives are located here. So select that. It's going to open a new tab. And here's the archives of the Mplab X Ide IDE for the Windows operating system, Mac operating system, and Linux. Depending on what operating system you're running on your machine, you can go through the documentation and find which one is best for you. And then go ahead and click which version you want, walk through the steps to download it. If we scroll down a little farther, so here we are at the Mplab X Ide Archives. If we scroll down past this, down these versions, eventually we'll hit Language Tool Archives, and then you'll see the Mplab XC8. And each one of these, they have the version number, the operating system, and then the date. So again, find the latest version for your operating system. So I'm running on a Mac, so I want the OS X version. If you're running on Windows, you're going to want the Win option here. And this compiler here is going to allow us to use C to code the PIC12. So before you open up the Mplab X software, we need to transfer the program and the associated files into the Mplab folder on your local computer. So when you downloaded the software, a folder directly should have been created within your file system. This is where the Mplab software will save project files that you create, and it's also where the Mplab software will look for already existing projects for you to edit. So we have already created a project with a script and a program, but for you to use it, you'll need to copy the version we provide and transfer it to the correct place on your local computer so that the Mplab software can find it, and then you can open it, edit it, and download it to the PIC3. So the folder in your local file directory should be called Mplab projects, like right here, Mplab X projects, but it'll be in your local file system. And once you've found this folder in your local directory, you're going to want to copy the files that we have here in this project. So all of these files here, you're going to want to copy them and paste them into that Mplab X projects folder in your local directory. And then once you've done that, you can go ahead and open Mplab X for the first time. But just to show you, so here's my local directory, and here's all my folders, and here's the Mplab project. So on the Mac OS, it's in your home folder, and there's a directory right here, file directory right here. On Windows and Linux, it's going to be different, but you're going to have to explore your own local machine to find the right place to transfer these files onto. And once you've done that, go ahead and open Mplab X. Now that you've transferred over the files into the correct folder, go ahead and open Mplab X. Like you see here, if everything was copied over correctly, the opening page should look something like this. You can cancel out of the start page, but here you'll see our the C code. Then over here under files, you'll see all the files that you transferred over. and here's your project folder. And then you're going to want to go ahead and connect the microchip Picket 3 to your computer via the USB cable. And so once that's happened, we're ready to upload the program to the Picket 3. Before doing this, though, you're going to want to make a small edit to a piece of code. This code will eventually regulate how often the temperature measurements are recorded by the logger. So if we scroll down to line 51 here and find the variable interval, here I have it set to 2000, which is approximately 20 minutes. But if you want to adjust the logging interval, you'll want to change this value. And the value that you'll want to input here into 2000s instead of 2000 will be the time in minutes, so 30 minutes, 60 minutes, 90 minutes, etc., and multiply it by 99.776, and then round this value to the closest whole number. And then you'll insert that. You'll change this value here to something else, maybe 3000, whatever you decide. And after you've set the interval variable to the desired value, go ahead and save the file. Next, after we make sure the Picket 3 is connected to your computer, we're going to go ahead up here to this icon, select the drop down, and we're going to select Programmer to Go, Picket 3/Picket 4, and make sure that the project is the temp logger project. Then we select that, we'll get some messages down here, and once it's successfully uploaded to the Picket 3, it'll say build successful, and then it's going to connect to the programmer. Alright, you're going to get this, you might get this message, and if it asks you, do you want to stay in Programmer to Go mode, just say no. And then it's going to say, make sure that the device you've connected is actually the Picket 3. It's going to send some voltage to the device. Go ahead and say OK. And then you'll get this message saying Picket 3 is now in Programmer to Go mode. So that's all set. This code is up on the Picket 3, so now we can go ahead and upload it to the PIC 12. Next, we're going to take our the PIC 12 683, and we are going to place it into the zero force insertion socket. Again, making sure that it's facing the right direction so that the notch is close to the lever. So we'll drop it in here like so, making sure that it's in the farthest to the right. Pins are in the farthest slots to the right, and the notch is facing the lever. And then we're going to close the lever, make sure that it's in there securely, and then we're going to attach this to the. All I have to do is press this button here, and then the status will go red. And once the status turns green, you're good to go. And this, the PIC 12F683 is ready to be installed into the data logger. Now, once we have the PIC 12F683 all programmed, using the PIC 3, we can install it into the circuit board. It's going to go up here in the upper right corner. Again, these chips have directionality, and so the notch on the PIC should match the notch on the socket. And so just like we did with the 28 pin, we're going to line up the pins here, and then press firmly down and make sure that it's in there and isn't moving around. And while we're at it, we can also take the DS1307 that we also ordered, and we can insert it into this socket here in the same way, matching up the notch on the component to the notch on the socket, and then pressing in firmly. And making sure none of the pins are bent. And the next thing we're going to do is install the SD card. So that just slides right in here. Make sure that the lock, it's unlocked. Some of these newer SD cards can lock. And then once you have all this ready like this, we're ready to go to the next and final programming step, which is to install the temperature probes and set the board to record. Okay, so once you have this all completed and ready for this final step, what you're going to need is you're going to need the board that with the chips, the proper chips inserted in the right spaces that we did in the last step, an FDDI friend, and the USB adapter to connect to your machine. Now to connect the data logger to the computer to upload the Arduino program, plug your USB into your machine. The micro USB goes into the FDDI friend like this, and then these 6 pin here plugs into the FDDI like so, and you're ready to go. So now go ahead and open up the Arduino IDE on your machine. In this step, we are going to upload 2 Arduino sketches to the temperature logger. One sketch to set the clock and the other sketch to install the external temperature probes that we built in step 2. So first, go ahead and open up the temp logger files, and then go to the Arduino files folder, and then open up the set clock.ino, that Arduino sketch. We will be working with this one first. Now, a quick note, for these sketches to run properly, they require a few external libraries. There are 2 ways in which you can install these libraries. The first way is you can go to the temp logger files, select Arduino files, and you can take the files that are in this library folder and you can copy them into the directory for Arduino that's on your computer. So you can find where the Arduino program stores its libraries. You can open that folder and you can transfer these files into that folder, and then these libraries will be able to be properly referenced by Arduino. Now, the second way that you can install libraries is you can go up to Sketch. You can go down to Include Libraries, and then you can select Manage Libraries. When you select Manage Libraries, the Library Manager will open up. Once the Library Manager has opened and fully loaded, you can use the search bar here to search through a compiled list of all the available Arduino libraries. Now, the libraries that we use in each of these sketches can be found at the top of each of the sketches underneath this commented section here. So every time it says include, that means we are including the library titled wire. The name of the library does not include the arrows or the .h extension. And that is the title. And so once you install that library, this include function will be able to properly reference it, and the sketch will work just fine. After you have the proper libraries installed, we will make a few edits to the sketch settings. So the first will be to go up to Tools, and we're going to drop down and we're going to make sure that the programmer setting is set to AVR-ISP MK2. Next, we're going to make sure the port is hooked up to USB serial, or whichever port the FDDI friend is connected to on your computer. And lastly, we're going to change the board to Arduino Uno. Once you have the appropriate libraries installed and your settings in line, you're going to go ahead and double check to make sure that the FTDI friend is hooked up to the board correctly and then connected to the right port on your computer. Your SD card in your SD card slot, and then you're going to come over here to upload, and you're going to select upload. You'll get a little message saying compiling sketch, uploading. The FTDI friend, the red and green LED will flash, and then it'll stop when they're done. And you'll get a message saying done uploading. After that, we're going to go ahead and close out of the set clock Arduino sketch, and we're going to go to the log temp Arduino sketch. And here it's the same thing. We're going to not change any of the settings, but we're going to double check to make sure that they're still the same. Arduino Uno, the correct serial port, programmer AVR ISP MK2, looks good. And we're going to double check to make sure that we have the appropriate libraries. Then we have the appropriate libraries installed. We're going to go ahead and upload this sketch. And when it's done, it'll tell you done uploading, and we're ready to move on to the next step. All right, so when we are finished uploading, press and hold the red button on the logger board and simultaneously keep it pressed while you click on the serial monitor option in the right-hand corner of the Arduino sketch, like you just saw me doing here. After a moment, a screen will pop up, and also the red LED will light up on the logger. It is important to keep the button pressed until the red LED comes on, like you see here in the smaller video on the lower right. So now go ahead and type any character in that bar there and hit enter, and you'll get a list of some readouts. So here you'll see that you've gotten some readouts. The first readout after the initialization is testing out to see if the board can write to the SD card that is installed in the board. If your SD card is in good shape and the programming in the previous steps were done correctly, it will say done followed by testing 1, 2, 3. The next readout will say the time and the date. This will reflect the time and date of the computer you were using when you ran the set clock Arduino sketch. The final readout says it's looking for temperature sensors. It will say that it found a single one-wire address. That one-wire address is the DS18B20 that is installed directly onto the board in the opposite corner from the SD card slot if you're looking at the board. Finally, we will report the temperature for device 0, device 1, device 2, etc. Here, the term device is synonymous for any temperature sensor. Also note that device 1 and device 2 are recording native 127. This is the default value for when the board is not receiving input from a sensor. Well, so device 1 and 2 aren't sending information because they aren't plugged in. So let's go ahead and do that. So go ahead and grab the 2 temperature sensors that you assembled way back in step 2 and go ahead and double check the orientation of the ground, signal, and power wires at the plug side of the sensor. After the first initialization and readouts, you should see the green LED turn on. This signifies that the board is ready to accept the temperature sensors one at a time. So go ahead and take your temperature sensor and plug it in one sensor at a time into the furthest position down, like I'm doing here. Again, just do one at a time. So one right now. Once that one is correctly plugged in, press the red button one more time. The green light should turn off and then back on after pressing it. which means that it's ready to accept the second sensor. So after you've pressed the button, go ahead and plug the second sensor in the immediately adjacent slot to the first one. And then once you have that one correctly plugged in, press the button one more time to end the sequence of adding probes. After the two sensors have been added correctly, the serial monitor window will add a few more lines of text which report the hex address of each added probe. The address of each probe isn't particularly important, but what is important is that all three of these addresses here that I'm highlighting are unique. Now, to check out if the installation actually worked properly, we will close out the serial monitor window and open it up again in the same manner as before. That is by holding the red button down, selecting the option to open the serial monitor, and then keeping the button pressed until the red LED turns on. And then once you get this message, type any character to begin adding sensors. Go ahead and type any character and hit enter. In this window, after you type your character, you'll see the same messages as before, except this time the temperature reading for device 1 and 2 should have values pretty close to device 0, the internal temperature sensor. Now do note that if you've been holding the sensors in your hand recently, that will increase the temperature reading for device 1 or 2. And with that, you're all done. So you can now unplug the temperature logger from the computer and move on to the next step, which will be to install the batteries and have it start recording. Now, to turn the temperature logger on and have it actively record temperature, add two AA batteries into the battery holder. And when you do this, you'll notice the single red flash on the red LED next to where the battery holder connects. That's just recognition for there actually being power supplied to the board. And once that happens, the logger is all set. It will now be actively recording temperature at each sensor at the interval you set onto the PIC12 and logging it onto the SD card.